Alright, welcome back to my channel, and today we're going to be talking about one-sided limits. So if you guys look back in my previous video, we just talked about in general what a limit is and an example we went over of how to solve limits. So this time we're going to be focusing on one-sided limits. So before, if you've noticed, it was limit as x was going to a, which is an arbitrary value, and we had a function f of x, and it would equal some value L, right? Now, we're going to take it a step further, and sometimes this A, it's not always going to be A. You're going to have a situation where it's going to ask you to do limit as x goes to A, and then you're going to have a minus as the power. And what that really means is just saying what is A from the left side. So remember when in the previous video, when we did 0.99, 0.9999, stuff like that, that was from the left side, right? So for example, 1. How do you go from the left side? You basically go like this. So all the values that become for 1 is like 0.5, and then 0.99, and 0.999, and so forth. So that's what this is basically talking about. It's x as it's approaching A from the left side, and f of x is going to L. And now there's the same thing, except you're going to have another one where you're going to have x is going to A from the right side. That's why you have a plus instead of a minus, and the f of x is going to L. So sometimes in some graphs, you will have where if A is going from the left side, you may have a different value, versus if A is going from the right side, you'll have a different value for L. But in some situations, they can be the same, which is a good thing, and there's actually something for that. So this is when x is basically less than A, because you're approaching it from the left side, and this is when x is greater than A. So that means you're plugging in values that are greater than A to figure out what it's approaching. Now, like this, you've seen this type of situation. Now let's say, as I talked about before, let's say if both of the values of L are the same, right? If this is equal to 3, and let's say from the left side, and this is equal to 3 from the right side, then it is safe to assume that that means without any positive or negative notation, like no positive or no negative, this is not there, then this would also equal 3. But let's say they're different values. Let's say this was 2, and this one's still 3, then this one does not exist, because the only way that a limit with no power of plus or minus would exist is if this L and this L are both the same. So remember, when the limit as x is approaching A from the left side equals the limit of x is approaching A from the right side, and they both equal the same L, then it's safe to assume that the limit of x as is approaching just A, that f of x, limit of x as is approaching just A, f of x is equal to L, the L value that you get that is same for all three of them. Alright, so now let's go through a practice problem for one-sided limits. So I'm going to draw a graph real quickly so that we can solve problems based on a graph, which will make it a lot more simpler. So I'm going to draw a graph, and it's going to be pretty simple, so I'm just going to put some numbers, 1, 2, 3, and then let's say we have a graph here, we're going to have a hole, and then we'll have another hole right here, and then we'll just draw another one right here, and then we'll just cancel that, and then we'll put a point here. Right, and then we'll call this f of x. We'll just call this graph f of x. Okay. Now I'm gonna ask you some limit questions. Okay. So now the first question is the limit as x is approaching 2 from the left side. That's why the negative for f of x, and it's asking what's that equal to. Right? Oops, I forgot to actually put these numbers. I'm sorry about that. I'm just going to put those numbers real quickly for us, and then we can continue on. Okay, so it's asking us to approach 2 from the left side. So first of all, look at your hand. So this is the left side, right? So we are going to do that. So as you're going from the left side to 2, you notice, okay, I'm going to stop right here. And what do you notice? I am at 3. Now, let's say I want to do the same thing, except the next question asks you the limit when it's from the positive side, okay? So I'm just going to erase this, and then we're going to solve it from the positive side. And now we're going to do the same thing we did before, except we're going to do it from the positive side. So positive is from here, this is positive, and this is the negative side. So we're going to go all the way to 2. The x value, remember this is x value of 2, so that's why we're going there. And you notice this time it's not equal to 3, and it's equal to 2. Now, 3, so when we did it from the left side, we got 3. When we did it from the right side, we got 2. So now, these values are not same. So when it asks you, what is the limit as x is going to 2, f of x, it's not going to equal 3 and 2. It's just going to be does not exist because the values are not the same. If they were the same values, then it would have been whatever that value of it was. Now, I'm going to ask you another question. It's the same type, except a little bit different than from the first one. So now let's say it's not approaching 2 anymore. Let's say we are approaching 4. So we're going to do a limit as x is approaching 4 from the left side first for f of x, the function over there. So for f of x is limit as approaching 4. So let's do it. So we're going from the left side. Remember, this is the negative side. So we're going to go to 4. And what do you notice? Okay, we're going to stop right here. Okay, and this is the left side. So it's at 3. Now, if I do the same thing for the right side, you also notice that it's also going to go to 3. So since both of them are going to 3, if there was no positive negative, let's say it was just the limit as x was going to 4, then for f of x, then f of x would be approaching 3 because from the right side it's 3 and for the left side it's 3. Now, you guys may be asking what this point is. So sometimes you could be given a question, what is f of 4? Now, it's not asking what the limit is, it's asking what f of 4 is. So f of 4 can't be a whole. F of 4 is where it's defined. Where's the point? So f of 4 would have to equal 2 because f4, it equals 2, y equals 2. But it can't be a whole because a whole means that value is missing, so it can't be defined at that point. But for limits, you can have wholes or you can have points. All right, so thanks for watching. If you have any questions, please let me know. Put in the comments down below any topics that you would like, anything you want. And thanks for watching, and bye.